Hello there. Assalamu alaikum. Good day, everyone. How are you all? I hope all you are in the pink. So today I am going to give a talk about a very famous problem, that is Bitonic Euclidean traveling salesman problem. So without making any further delay, let's get started. So before giving the presentation, let me give a brief about myself. I'm Ifal Haq. I'm a student of Institute of Information Technology in Oakland Science and Technology University. I would like to thank Mohammad Wahidur Rahman Shuman sir for giving me the opportunity to give this today's presentation. Okay, so let's get started. So today we are going to talk about what is basically traveling salesman problem. What is the exact problem of it? How, okay, what are the methods there to solve this, okay, solve this famous problem, and what is the TSP algorithm? Then we'll see, um, can it be, okay, could it be possible to solve this problem using greedy approach? If this greedy approach fail, okay, what are the other approach? We'll see that there are possible methods like brute force approach. Then we will see, okay, then we will try to solve this TSP using dynamic programming approach, and then we will see the code implementation, and then we'll see the application of traveling salesman problem. So moving on, what is basically traveling salesperson problem? TSP problem is a very famous problem in computer science, and it is also known as NP-hard problem because the standard version of TSP is a very hard to solve. Okay, so what is basically traveling salesman problem? Suppose there are 10 cities in a country. Okay, a tourist have to visit every cities. A tourist have to visit every cities. So now he will, he will start his visit from a city, and then he has to visit exactly once of other cities, and then he has to return back to the city where he started. Okay, so here it's called that given a list of cities and distances between each pair of cities, what is the shortest possible path? That means tourist has to find the shortest route or the shortest distance between the pair of the cities. Okay, so let's see an exact problem of it. Suppose there are four number of cities, that is A, B, C, D, and the distances of each pair of cities are given. So what will be the possible shortest route that visit each day, that visit each city exactly once and return to origin city? That means the city where the person or the where the tourist has started. Okay, so what are the methods to solve the problem? There are a number of methods like genetic algorithm, branch and bound method, dynamic programming method or approach, optimal solution, that is more precisely brute force approach, heuristic algorithm, Hungarian method. But today in this presentation, we'll try to solve this problem using the brute force approach and as well as the dynamic programming. Let's see. Let's see the algorithm of TSP or traveling salesman problem. So what is basically? Think that S is the starting point, N is the subset of input cities. The dist function is basically distance or the cost or the weight among the cities. Okay, so if the n is equal to 2, that means if the number of cities or number of nodes are 2, then the cost will be it n comma k distance s comma k. But if the number of cities are more than 2, then the cost will be n comma j is equal to minimum tsp n minus I comma j plus distance I comma j. Isn't it hard? Let's see. We'll try to, okay, we will solve a problem using the brute force approach and the dynamic program. Then this algorithm will be so much clear for it. Let's move on. Okay, so the problem is a there are four cities A, B, C, D. The adjacency table is given. Adjacency tables are representing the cost value or the weight value or the distances between the pair of the cities or the nodes. Okay, so at first, let's see if it will it be solve this problem using greedy approach. So using the greedy approach, we can choose any number of what any number of cities, that means any routes. So let's say we can choose any route that is A, B, D, C, A. By using that, we find that we found that the route will be 15. Is it the correct solution? No, because there will be optimal solution. So that means the greedy approach has been failed there. So let's see, as the greedy approach failed, is there any um, better approach or better method to solve it? Let's see. At first, let's see the brute force approach. So what is basically brute force approach works? Brute force approach works on, like, they're working on every possible solution. Let's see, the A is the starting node. Then we can go to B, C, D. From B we can go to C or D. From C we can go to D, and then we will return back to A. That means return that means we'll return to the node where we started. Okay, so by using that we can find the root, like A B C D A B D C A C B D A C D B A D B C A D C B A. Among these routes, what will be the shortest one? By calculating the distance or the calculating the weight value, we found that the cost value, the minimum cost will be ADCBA, and that is 10. So the possible solution will be n minus 1 factorial, and the time complexity of will be order of n factorial. Are we able, will we able to reduce the complexity? Let's see. So using dynamic programming, we have already seen the algorithm of it. Like, if the S is 2, that means the number of cities is 2, then the cost value will be C S is equal distance I comma, and more than 2, then the cost will be it C S comma N minimum. Okay, so let's solve the problem using dynamic programming. By solving the dynamic programming of where using the number using the DSP using the DSP algorithm, we can found that the shortest path or shortest route will be ADCBA, and that is 10. We have already solved this problem using brute force approach, and we get the same solution of it, right? But what is the correct approach? Let's see. In the By using the brute force approach, the time complexity is order of n factorial, but using dynamic programming the time complexity has been reduced, and that is order of n is squared into 2 to the n. So best what is the best solution, or what is the um, optimal solution of this problem? By using Dan, we can say that the using dynamic programming, we can find the correct optimal solution. Okay, let's see the code implementation of TSP using dynamic approach. In here we have implemented the TSP algorithm. You can see that minimum path will be, and the and the all the adjacency matrices, and let's see the output of it. The output will be 10, as we have already got it. So what is the application of traveling salesperson problem or TSP? The application of TSP is like a real world application in Google Map. While we are trying to find the shortest route from the nodes or from the cities or from any particular um, places, we can find the shortest route by using this algorithm. That means Google Map or other relevant project are have used this uh, algorithm, more precisely traveling salesperson problem. That's why it is very much very famous problem. So in the conclusion, we can say that it can be concluded that an application of TSP algorithm with dynamic programming is able to produce optimal route to serve customers, including shortest or minimum length of travel time. Okay, so these are the things that I have tried to explain in this presentation. So if anyone have any question or any doubt, please write down the question in the comment below. And thank you so very much to everyone. Assalamu alaikum.